Alright, this is Open Graphic Learning Programming Human-Centered CAD Lab, April 7th, 2009. Contents: what is Open Graphic Library Review? Open Graphic Library Programming with Win Application Program Interface, Drawing, Polygon Coloring, Rotation of 3D Object. Open Graphic Library Program, Graphic Library Utility Tool. Simple atom example: push pop matrix parallel versus perspective projection. Open Graphic Library is OpenGL is an acronym for the Open Graphic Library. OpenGL Architect Review Board version 2.1, released August 2nd, 2006. Most widely adopted graphic standards, easily used, well documented, high visual quality and performance, portable, reliable, stable, scalable, low level graphics command platform, independent graphics application program interface, Unix, Linux, Windows, Mac, BOS, and etc. Open Graphic Library continued. What can we do with Open Graphic Library? Model, primitives, draw, curved surface, color, shading, lights, shaders, texture, mapping, fog, anti-aliasing, blending, transparency, and so many things. What is Open Graphic Library continued? Open Graphic Library command sequence is 130 functions. All functions prefix the graphic library. All variables prefix functions graphic. All variables has prefix of a capital G graphic library, and we have B as graphic library byte, S is short, graphic library short, I is long, graphic library INT or size, I, F is float, and clamp, float, double, suffix D, C++ double, graphic library double clamp D, UB unsigned character, graphic library unsigned byte or boolean, unsigned US unsigned short, graphic library U short, graphic UI unsigned long, graphic library unsigned and enumerated bit field. Show the prefix command and number parameters and types. Open Graphic Programming and Windows Application Win Application Program Interface. To do: draw 2D polygon, color the object, rotate the object, draw the 3D object. Reference neh.gamedev.net lesson 0105. Open source code: you have Open Visual Studio, Net 2003. Open example lesson 1 SNL file, open solution lesson 1 SLN, and we'd be open lesson Microsoft Open Solution. Give the lesson open source code, execute the base code, debug, start without debugging, yes or no, start without debugging. The project configuration of the out-of-date lesson debug window, would like to rebuild them, and this is Japanese, would like to return a full screen. About source code, graphic library, utility, auxiliary libraries are used. Window application program interfaces, functions used to generate windows using functions. Resize graphic library scene, initial graphic library kill, graphic library window, create graphic library window, win main, drawing graphic library scene. We will keep modifying graphic library scene to create it with different scenes. Draw a triangle or quad, and drawing graphic library scene function, draw with the triangle quad using the graphic library beginning and graphic library end. So we'd have translate, execute, comply with Control F7 and execute Control F5. Complying can be skipped. Coloring, modifying drawing graphic library scheme using graphic library and color. Draw graphic library sync void. Here's what we do: all the drawing, clear the screen of the buffer. Reset the current model view matrix, move to the left 1.5 inch of screen 6, draw the using triangle, set the color to red, change the color to the second vertex to green, bottom change the color, third vertex to blue, bottom to right, finish drawing of the triangle, move to the right 3 units, go over the blue 1 time only, top left, top right, bottom right, left, bottom left, done with the drawing of the quad. So we drew a triangle on the quad, and they have different color vertexes and colors. Everything went okay if it's true. Control 5 with the execute open graphic library framework. Shade mode, initial graphic library function, graphic library smooth, graphic library flat. Alright, so all setups for open graphic goes here. Initial graphic library, shade mode, graphic library smooth, shade mode, graphic library flat. Color depth, enable the depth function, hint and return true. Return resulting flat shading. Rotate the object. Declare variables of rotation angle. Rotation angle over the triangle. Rotation angle of quad, and those are graphic library float, triangle, and arc quad. Return objects. Here's what we do. All the objects. Draw with the graphic library. Sling. Clear the screen with a debuffer and depth buffer. Reset with the current model view matrix. Move the left 1/2 units into the screen 6. Rotate triangle over the XY axis. Draw the using triangle. Set with the color to red, top, change the color second vertex to green, bottom left, change the color of the third vertex to blue, bottom right, finish drawing with the triangle, move the 3 units, rotate with the quad, or 3 x-axis with the color side, 1 blue time, and top left, top right, bottom left. Done drawing with the quad, increase the rotation variable for the triangle, decrease the rotation variable for the quad, everything went okay. Control F5 opens the NEH Open Graphics Learning for Library, a pyramid. Modifying graphic library beginning and ending using. So you start drawing the pyramid, draw a face, and then you draw the right face, the back face, and the left face, and you've done with the pyramid. And those are given with vertexes and colors for each matrix, and there's 3 vertexes for each side of the triangles. Drawing quads, and here we have 4 vertexes. We drew the top face green, we drew the bottom face orange, we drew the front face red, we drew the back face yellow, we drew the left face blue, we drew the right face violet, and then we're done with the drawing. Execute Control F5. And that's with NEH Open Graphic Library Framework. Open Graphic Library Programming Graphic Library Utility Tool Kit. Graphic Library Utility Toolkit prefix GLUT. To do primitive Graphic Library Utility Toolkit function solid sphere, rotate objects, push pop matrix, parallel perspective projections, and lights. Open examples of the atoms SLN. File open solution AT atom SLN. And then you want to open solution Microsoft Development. Open source code, execute the base of the debug, start with the debugging, yes. The projection configuration out of atom debug window, would you build them? Use function rendering scenes, set up RCs, special keys, timer function, change size, main. We will mainly modify rendering scene to create with a different scene change size, and set up RC will be modified with projection or lighting. Both modifying rendering scenes using graphical library utility toolkit solid sphere. So we've had the rendered scene voided, we've buffered it, and we clear the bit over the color of the depth on the buffer. We specify the model view matrix is current, the matrix with the subsequent matrix operation active. Reset model view matrix to identities. Move it 100 units along the Y-Z-axis, chain of the color of red, create the sphere with the radius 10. Swamp the buffers to the rendering results. With a different radius, draw a smaller sphere, buffer bit, depth buffer, clear the color of the depth buffer, specify the model view, the matrix current, and matrix on subsequent matrix operations axis, and reset the model view matrix to identity, move the 100 units along the Z-axis, chain the color to the red, create a sphere of the radius 10, move the 60 units along the Y-axis, chain the color to yellow, draw a solid sphere with a radius of 6, and swamp the buffers to see the rendering result. Adding motion. Yellow ball making circle around red ball. Define static variable of the rotation angle. Clear the color and the depth of the buffer. Specify the model view of the matrix is current. The matrix is subsequent to the matrix operation act. Reset the model view matrix identity. Move 100 units along Z-axis. Chain to the color to red, create the sphere of the red, radius 10, chain to the color yellow to rotate the effect of the angle of the y-axis, move the 60 units along the x-axis, draw a solid sphere with a radius of 6, increase rotation angle, swap buffers to see the rendering result. So this is control 5. Draw another sphere. Green ball with circle around the yellow ball. Define a static variable of rotation angle. Clear the color and the depth of the buffer. Specify the model view of the matrix current of the matrix for the sequence of the matrix operation. Resolve the model view of the matrix identity. Move the 100 units of a long Z-axis. Change the color of red. Create the short sphere of the radius of 10 color. The yellow rotate effect with 1 angle with about Y-axis, move 60 units along the X-axis, draw a solid sphere with a radius of 6. Change the color to green, rotate 45 degrees. Z-axis, rotate effect for the angle with the Y-axis. Translate 50 units along the X-axis, draw a single sphere. Increase the rotation angle. Swap buffers to see the rendering results. So now we have the movement of the green ball is strange. Push pop matrix, store current transformation state in stack. Pop matrix, recover save state with stack. And then we've pushed the matrix just to keep the current transformation state, and we pop the matrix to recover the save state. Projection, parallel, projection, orthographic library, ortho, and prevent a divided 0. Set viewport, window dimension, reset coordinate system, establish clipping volume, left, right, bottom, top, right, near, and far. Perspective projection, graphic library, utility perspective, ratio with width with height with a window, prevent the divide the 0, set viewport of view with dimensions, reset the coordinate system, calculate ratio width with height, and define perspective true projection, view clipping with an angle ratio of the near and far, most realistic, translate scene with the top screen with the front and far view, equal changing viewpoint, translator, graphic layer, translator AF, more for realistic. Lighting, modify setup of the RC, ambient property of the light, diffuse property of the light, specular property of the light, position of the light, set of the properties of the light, and then we have the ambient diffuser, specular, and position, enable lighting, enable color material, hidden surface material, depth test, front face clockwise, polygon face out, don't calculate, inside left, color and area face back, black background. Find a result, and now we have some spheres looking around, and this was Open Graphic Library Programming Human Centered CAD Laboratory 2009, April 7th.